All right, so yesterday I think we ended with vanadium, okay, and we did that one. And we have this chart that we've been using, so I kind of had just like put it up here so we could look at it better and refer to it instead of me holding it up. So we're just going to pick one today. We're going to do, well, let's do bromine, okay, which is right here. Okay, so right there. So if I look at where bromine is, I can see that bromine ends in the 4p5 slot. So we know that it's going to end in 4p5. So I am simply just going to fill up all of the orbitals underneath there. And remember, we start at the beginning, so we start here, and we fill up 1s, correct? With an up and a down. After we go and fill 1s, we now come and read on the next line. It is 2s. So we write 2s, up, down. After we fill 2s, we keep going and we come to the 2p's. How many orbitals are in any p orbital? 3. Hold 6 electrons, but there's 3 orbitals. So for 2p, I write 1, 2, 3. I'm going to fill those up because bromine's down here. I got to keep going. So I go up, 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 down, down, down. Now I finish my 2p and I come to the next line and I go to 3s. So I draw up and I draw down. I keep going and I get to my 3p's. 1, 2, 3. Up, up, up. Down, down, down. I finish out my 3p's and I come to the next line. 4s. And I'm filling there, up and down. Now I go through 4s and now I come to 3d. How many orbitals are in a d? 5. So I'm going to draw 5 lines. 1, 2, 3, 4, 5. I'm filling those up. So I say 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. After 3D comes 4P. How many am I going to put in there? 5. So I write my 4P and I say 1, 2, 3. And then I say 1, 2, 3, 4, and 5. So that is my orbital diagram or my orbital notation. My electron configuration would just be writing what we just said instead of with arrows. So we would say 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p5. Okay? If I want to do the quantum numbers for the last electron, this is my last electron right here. Okay? It's the last one I put in there. Be careful about seeing that it's a 5 and you didn't count, you went 2, 4 like that. Count them in order that you fill them when you're doing it. Otherwise you can make a mistake. So the first quantum number is your energy level. Always comes from whatever number you wrote here. So it's going to be 4. Okay? The second quantum number is what kind of sublevel are you in? An S, a P, or a D, or an F? P. I'm in a P. So remember, that's their L value. They can be S, P, D, or F. Corresponds with 0, 1, 2, or 3. So I'm in a P orbital, so I'm going to put a 1. Okay? The next one is your M sub L. And it is negative L to big L, positive L. Start here, negative 1, 0, 1. So I'm in the middle position, so it is in the 0. And it's going down. So it's negative half. That's for the last electron. I can give any electron in there some quantum numbers. Okay? Matter of fact, on the test, there will be some where I might ask you for one of the quantum numbers in the middle. Okay? For instance, let's do what are the quantum numbers for the first electron? Right here. 1, 0. If this number is a 0, what does the next number have to be? A 0. You can't have a negative 0. You just have another 0. And it's up, so it would be positive half. Okay? Is it making a little bit more sense? We're gonna do another one, okay? So that's how everybody at least gets that this 1s2 is corresponding to that 1s2, right? And that you just read these across, okay? It's like reading a book, okay? So let's do another one. This time we're going to do americium. It's 95. It's right here. Okay? Yeah, whoops. I don't know how, I didn't know I could get that to come back. Learned something new today. Americium. It's got 95 electrons. And we expect that it should end in a 5f6. Okay? 5f6. So we're going to do this together. Are y'all ready? We're not drawing the arrows for this one, by the way. We're just going to do the electron configuration. We don't have all day to draw all 95 arrows. Okay? So y'all are going to start me off, and then y'all kind of hand off to each other telling me what comes. And remember, I got it right, so don't tell me too fast, even though I could say it really fast. So I always start with 1s2, 2s2, 2p6, okay, now someone else. All right, 3d10, what comes after 3d10? 4p6.
6s2.
No.
4f14.
Yeah, I got to come down here and pick up these F's. So it'd be 4f14. Now I go back up here, 5d10, 6p6, 7s2, and I'm going to stop you there. Okay? And that's because these are tricky. You see these little numbers right here. On your paper that like you have like mine, they're up in the top. On your actual periodic table, they put them down in the bottom, but they fit in right here. It's called the lanthanide and actinide series. Okay? They actually start after lanthanide and after actinide. Okay? So, while ago we were filling up the F. Okay? So we just say 6s2, 4f, and then we go back and pick up the 5ds. However, if you are stopping somewhere in the F block, you have got to include the 6d1 or the 5d1 because it technically fills before the F's. Okay? So this one we would say 6d1, then we would say 5f6. Okay? You only do that if you stop in the F block. If you're filling up the F block, you just fill it and then go back to your D's. Okay? But if you're stopping down there, technically the 5d1 and the 6d1 fills before the first F does. Okay? That doesn't show up very often, but it does show up. Okay? So now that's how we would write the electron configuration. It's very tedious. So I'm going to show you a shortcut. Okay? It's called the noble gas configuration. Okay? And what it does is it allows you to use the noble gas that comes before the element, because you hopefully realize by now that whenever we add an electron and we add an electron, the next element is only one electron different from the element that came before it, correct? Okay? Your noble gases are right here, of course. They all end in P6, which is a full octet, which makes them stable, which we'll get to octets when we get to bonding. You can only do this with noble gases, okay? The biggest mistake kids make is they just pick any random element on there, and then they use it as a shortcut. If it would be called any random element notation if we could do that. It's noble gas configuration. So for your americium, the one that comes before it is radon. So we would write radon in brackets, okay? And the reason we can do that is because radon's right here. That is the electron configuration of radon. So we write radon, and then we put what comes after it. 7s2, 6D1, 5F6. All I did was start from radon and keep reading like we were doing. I just gave ourselves a shortcut. Okay? If I wanted to figure out what the last electron was, okay, what I would do is I would just draw the orbital diagram for the last part. So in this case, I would say 5F. How many orbitals does an F have? 7. 1, 2, 3, 4, 5, 6, 7. And then I would say 1, 2, 3, 4, 5, 6. Negative 3, negative 2, negative 1, 0, 1, 2, 3. So I would say my last electron would be 5, because I'm in the 5th energy level for the last one. How do we signify an F orbital? 3. It's in the position of number 2, and it's spinning up. So that's how I would do that. Okay? So now we're going to try one or two with just the noble gas configuration so I can make sure you understand it. Okay? If I was going to use chlorine, what noble gas would I use?
Neon.
Neon. If I was going to do cesium, what noble gas would I use?
Xenon.
Xenon. Cesium's right here. Okay? It's always the one that comes before it. Okay? So let's do a couple. So we just said we would do, let's do cesium. So we would say cesium, we would just use xenon. And then we would say 6s1. A lot easier, right? A lot easier than saying 1s2, 2s2, 2p6, blah, 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 all the way till you get to 6s1. So that's how you would do that. Okay? If I was going to do 10, like the element 10, not the number 10, 10, I would use krypton, put it in brackets, and then I would just keep reading. After that, I would say 5s2, 4d10, 5p2. Much easier, right? But if I had shown you straight to noble gas and not the other one, you wouldn't understand why we were doing it. So I have to teach you the long way before I can teach you the shortcut. Okay? So your worksheet from yesterday is due on Tuesday. I'm going to do iron with you. So don't do like one of the class periods today. I did iron with them and then they came up to show me to get help and they didn't even write it down. So write down iron on the paper. Okay? Iron is 3d6. It's right here. So we're going to end in 3d6. So we know that. So it's a good idea when you know what element you're doing, you can identify it based on where it's at in the table. Okay? So I would say that I would write, well, you tell me, what element would I use? Which noble gas would I use? Argon. And then I would write 4s2, 3d6. Okay? To draw the orbital diagram on this paper, they're only asking you to do the orbital diagram after the noble gas. Because quite frankly, the noble gas ones, all underneath there are core electrons and nothing really happens with them. When they're participating in reactions, the core electrons don't do anything, they just hang out and watch. It's all about the valence electrons in the outer shells. So I would say 4s, up, down, and then 1, 2, 3, 4, 5, that's a 3D. 1, 2, 3, 4, 5, and 6. So what would my quantum numbers be? 3. I'm in a D, so how do I signify a D? 2. Negative 2, negative 1, 0, 1, 2. So I would be negative 2. And it's pointing down, so negative 1/2. Okay? So on this worksheet, they're going to give you different aspects of that, and you got to figure out what the rest of it is. Okay? So if I was to say, what ends in 4p3, what would you tell me ends in 4p3? Look at your periodic tables. What ends in 4p3? Arsenic. What ends in 6s2? Barium. Okay. How about 6p2? Lead. So you getting the hang of it, how you do this? All right, so I'm going to let you work on your worksheet, and I'm going to walk around and help.